Good day to you and a warm welcome to the demonstration of Global Analytics for Bridge Management, or GABM in short. So what is GABM? GABM is an internet free analytical tool for bridge management applicable globally to arrive at the three objectives of the bridge management, namely deterioration modeling, risk analysis, and fund optimization. Being an internet free application, it is very cost effective and very efficient. The results, the three objectives of bridge management are arrived after you complete the submission of the required data in a matter of few seconds. Before we log in into the GABM application, we have to ensure that we have all the data required for input. Once you log in onto the GABM portal or application, what you see is the instructions sheet. On the top right hand corner, you will see a red button which indicates download the user manual. Now, this user manual is a user friendly set of instructions which helps you understand what inputs are required and how they can be provided in the application. Once you move ahead, and if you look at the menu on the left hand side, you will see four icons. One is instruction, bridges, settings, and logout. The instruction is the one that we have seen. Now we will go to the settings. Under the settings, you have four sub menus. One is standard cost, import database, and save database either on email or on your device. Now, standard costs are certain figures that are essential for evaluating the results of that GABM achieves, and these are constant for that particular year of input. So if you see here, we have created a database of about 10 or 11 years starting from 2014 to 2023, and you have various heads of inputs. Now if you go to the bridge menu and you click bridge, you will see a list of bridges that have been created to show the demonstration. You have 11 or 12 bridges in this list, and ahead of each bridge, on the extreme right side, you will see history output, and in front of certain bridges, you will see an alert indicating that the bridge has to be inspected now. Now, these alerts help the user in the department to understand which bridges have to be inspected. The alert follow a protocol of once a year inspection. If you need a lesser time, that modification can be done within a few hours. So the alert will indicate the time that you specify for the inspection. Now, if you click at the history, let's take bridge number 2 history. If you click at the history, you will see the historical data that has been input and the output for this bridge over the period of years it has been inspected. In this case, it has been inspected for the full 10 years, starting from 2014 to 2021 or 22. Now, this bridge has an alert. Bridge needs inspection now. It indicates that this bridge was inspected a minimum of 10 months ago. It could be more, but a minimum of 10 months ago. If you look at the output of this bridge, you will see another alert that the bridge is in critical condition and it has to be closed for traffic. Now, these alerts are provided right at the front to enable the department to understand which bridges are in critical state, which bridges are in severe distress, and which bridges need inspection. This is the overall summary of this application. Now, if you go to a particular input, now we will take any bridge which has the alert, bridge needs inspection now. And if you look at the historical data of that bridge, on the top right side, you will see add iterations. That means add inspection data. If you click that, you will come to the first screen, that is the bridge identity number, in which you have to fill the required data. And these are standard data. Where is the bridge located, year of inspection, and certain other details that are essentially common. Length of the bridge in meter, total span, span length, and then you come to the bridge classification number, which has traffic lane, type of road, age of bridge, and payload. Then, once you have completed this basic data about the bridge, you come to the next stage, that is the bridge structural rating number, or BSRN. Now here there are 4 ratings that you have to input. One is deck rating, superstructure rating, substructure rating, and scour rating. Scour or indicating foundation rating. Now these are 4 main components of the bridge. We understand that ratings are allocated either component wise or subcomponent wise. That is, in superstructure you have component for a girder in a span. If there are 4 girders, you will have 4 ratings for the girders in the span. If there are cross girders, you will have ratings for the cross girders, so on and so forth. If there are multiple ratings in the superstructure, we can provide a statistical averaging system where weightage for every element can be provided and the rating can be input, resulting in a single rating that is required for GABM. Now, when you click on the icon I shown near the deck rating or superstructure or substructure or foundation, you will get the brief outline of the option that has been provided. So click on the I rating and you will see what does 1 mean, what does 2, 3, 4, 5 mean for each of those rating numbers. Having inputted the structural rating numbers, you reach the functional rating numbers, which has deck geometry, vertical clearance, waterway, and ADC, waterway adequacy and ADC. When there is no waterway, 1 number can be allocated and that solves your problem. When you reach to the socio-economic rating number, now this is a unique feature in GABM. Socio-economic rating number owe their existence in GABM to the previous IBMS or UBMS version of bridge management applied in India. Now this has the data for social importance, economic growth, alternate route, environmental impact. Having understood these, you can get the details of each of these ratings in the icon I. Probably for the first few bridges you will have to refer to these detailed description, or you can always refer to the user manual, which has more clarity as to each of the rating numbers for social importance, economic growth, alternate route, or environmental impact. Now 3 of these ratings have a direct positive impact on the bridge environment or bridge surroundings. One, environmental impact, deals with the negative impact of this bridge on the environment surrounding the bridge. Having completed the ratings, we then go to the cause matrix. Now, cause matrix is a novel methodology for collecting data about the distress in the bridge. World over, on most of the bridge management, engineers deal with symptoms. From symptoms, how to reach the cause. To give you a brief example, you sneeze. Sneezing is a symptom. Having cold is a cause. Having irritation in the nose is the cause. Having congestion in your chest is a cause. So, similarly, symptoms in the bridge are easily correlated to the cause, and each of these causes again have ratings, and the details of these ratings can be found in the icon indicated next to each of these causes. Once you fill in all the causes, then you come to an option of applying structural health monitoring, short-term structural health monitoring. Could apply to get a better understanding about how this is provided in the output. So if you click the box there, do you want to apply SHM? You click that box, and then the ratings provided indicate the reduction in the performance of the bridge that has been observed under short-term SHM for 3 or 4 cycles, each of the cycle being observed in say 3 months or 4 months duration. The maximum reduction in performance is converted to a number 2 or 3 depending upon the reduction. The reduction could be 20%, 30%, 40%, 50%, and then accordingly the ratings are given. And once you provide that input, that is all that is required. We are not worried about what type of performance is being observed, because performance of the bridge distress element under live load is an overall assessment of the bridge, and that is what we are looking at. Having completed this, then you come to life cycle cost analysis data, and that is related to the construction cost per kilometer for the bridge, years over which investment is spread, and the conversion ratio from financial to economic, which is generally between 0.75 and 0.95. Having completed this, you see a small button on the right side, evaluate. When you press evaluate button, the application asks you to confirm or change. Once you confirm, there is no way you can change the data that you have inputted. But if you say change, you can go back to the screen on which you need to change and change that input. We will press confirm, and within 15 seconds here you see the results. We have the deterioration model created within 10 or 12 seconds. Simultaneously, the fund allocation optimization has been completed, and data will be seen when we go to pre or post SHM analysis. Now, this deterioration and risk modeling is completed, and you are provided with a result in balanced service life, absolute balanced service life. Now, balanced service life indicates the available service life for the bridge if no remedial action is taken. If you take a remedial action within that, obviously ratings will change, and then you will see the improvement in the bridge balance service life. Now, if you look at the top, shall we go to the bridges? And from bridges, we can go to pre-SHM or post-SHM. We will see both these results. Now, when we choose pre-SHM, I am asked to select the age or year for which pre-SHM analysis is required. The advantage of this system is you can see the fund allocation protocol or fund allocation optimization for each of the past years also. So bridges which were required to be provided input have not been repaired, and subsequently the same bridges occur. That means repairs have not been completed or repairs have not been done. So if you look at pre-SHM 2017 data, you will see a list of bridge. And if you click on ranking, you can change the ranking from ascending to descending order. If you click from ranking, you will see 1, 2, 3, 4, 5, 6, 7, 8, 9, the number of bridges. If you move a little right, you will see few of the bridges have indication of repair recommended, and few of the bridges you have BUOM. BUOM, the full form is Bridge Under Observation and Monitoring. Now these are the bridges for which you can apply SHM and get more detailed analysis, because these bridges are in need of repairs, but you are not able to provide because the cumulative repair cost of the previous bridges have surpassed the departmental budget. Now, departmental budget for that year has been input in the standard cost under settings. So once you know that departmental budget, automatically only bridges for whose bridge rehabilitation cost the cumulative total doesn't exceed the departmental budget, that comes under repair recommended, and others will fall under BUOM. Now if you look at post SHM analysis, you will again need to input the year. Let's take 2018 as the year, and you will see bridges under post SHM criteria. Bridges for which were under BUOM and have been applied, results for which are available. Now here you will see that you have more data, because apart from the balance service life and absolute balance service life of SHM or pre-SHM, you have balance service life and absolute balance service life post SHM also. And then you have financial indications also. Using life cycle cost analysis, we have calculated the internal rate of return, the direct internal rate of return, without accounting for any enhancement resulting from socio-economic ratings, and the enhanced internal rate of return calculated applying the input from socio-economic ratings. And then you have three parameters: the engineering index, the financial index, and the sustainability index. You can toggle any of these to modify the methodology for fund optimization that you want to apply. You just don't need to rely only on engineering properties. You can rely on engineering properties or financial properties or sustainability index, either individually or collectively in the last column, wherein a certain weightage is allocated for each of these. In this case, we have allocated 40, 30, 30. So 40 are for the engineering index, 30 for the financial index, and 30% percentile for the sustainability index. So this entire result has been calculated at the same time when you see the deterioration model. So this is the entire GABM. The advantage of GABM application is that all this is available even for micro bridge inventory owners. Bridge inventory owners who do not have more than 30 bridges, 40 bridges, 100 bridges, 200 bridges in their portfolio are today kept away from application of bridge management because of the cost factor and the complexities involved. Here you will see that the data inputted is say about 35-40 parameters instead of 200-300 parameters that most of the bridge management systems have. This has brought us to the end of the presentation, and we can log out, and that is all. If you have any questions regarding this, you are free to send us an email at ubmsresearchgroup@gmail.com, and we promise you to reply to your questions. Thank you so much.